we said that volume is proportional to the number of moles, right? Currently, there's X number of moles of gas in this balloon. Well, if I put more moles of gas in the balloon, what should happen to the volume? Okay. So you guys have done this since you were little kids, right? You've blown up balloons. Ideal gas law, right? That's a component of the ideal gas law. It's Avogadro's law. I need to get this bigger so that I can do other stuff with it. Okay. Got a big beaker here. Charles' law. Charles' law is that volume is proportional to temperature, right? So I've got some volume inherent to that right now. I've got something, it feels warm in here. It's probably about 298 degrees Kelvin. Okay, I'm going to say. This is 77 degrees Kelvin. So, what should happen to the volume? Decrease, okay.
Oh. Ooh.
Yeah, you're like, get it on the front of your pants. It's not very good. Okay. Get it.
Ooh. It just evaporates.
Yeah, it's the best way to dust.
The dust? Yeah, dust the floor.
Yeah. Okay.
Yeah, because it moves it. The air is moving. Ooh. Hot.
Okay. So this is just liquid nitrogen. It's not going to hurt you. Okay. We're in a big enough room that the nitrogen's not going to displace all the oxygen. So what should happen is it raises back to room temperature. Yeah, the gas inside the balloon should re-expand. Right? It warms back up. So volume is proportional to temperature. Now it'll take a little while, unless I pop it. I didn't pop it. Okay, good. All right, so we've got visual representations of Avogadro's law. We've got a visual representation, okay, of Charles' law.
Ooh. It's stuck in the thing.
Yeah, it is. So what are we missing? Pressure. Okay, so Boyle's law. Boyle's law is that volume is proportional to 1 over P, right? So now in this case, if you don't like loud things, this may or may not be loud. I never remember. I think it'll be okay. This is a water bottle.
Oh.
Just in case. Okay. But this is methanol.
Oh.
Okay, so it's empty though, almost. Put a little bit of methanol on here. Then I'm going to shake this up. Okay.
Oh, a big old fire stopped.
It didn't light.
Oh.
Maybe my methanol's too wet.
No way. It is too.
Is this what the commercials were talking about?
That's what happens.
What's that?
Your mattress.
Oh, I don't have enough. Hold on. It shouldn't be this wet. He's got his sunglasses on because he knows I'm bright and shiny.
Yeah, I was going to say that it'll be my luck to get hit with something.
You're not going to get hit with something.
Is there a splash zone for chemistry?
There will be in some of these. Alright, that is a common demonstration reaction from me. Yes. Alright. Okay. Well, what just happened?
All of the gas is gone.
Okay, all the gas has gone out of it. My atmospheric pressure, though, has not changed. It'll get louder again here in a second. Oh, is there an awesome picture? Word. Okay. Throw that on Snapchat. Yes. This is why my class is so much fun. Okay. So why did the volume decrease?
Because ignition.
Okay.
There's so much gas in there, it ignited, pushing all of it out because it would
Good.
follow that, following the temperature out into the room diffusing, and then after that, there's a vacuum left there, you closed it off.
Okay, so in this case now, instead of having the same pressure inside and outside, I have a lower pressure inside, which means the higher pressure is going to result in a smaller volume. Okay. Oh, good, I just melted it instead. Sometimes when you let go, it really makes a really loud sound, but Home Depot hates me. There are water bottles now. Okay, so that's a visualization of Boyle's law in terms of an external pressure exerting more force on an internal pressure and therefore compressing the volume. Okay? Any questions? Yeah, Dan.
Sorry, repeat that one more time.
Okay, so in this case, I have a higher external pressure, which means I'm going to compress the volume that's in here, or the total volume, because I have a lower pressure inside.
So the outside pressure like caves in the smaller pressure?
Yeah. So originally when I started, hold on, let's see if I can. Okay, it's not going to go. When I started and it was still cylindrical, the pressure inside and the pressure outside were the same. So it kept its form. When I ignited the methanol, it pushed all the air out of the container. And then when I put my hand on it, I have very few molecules inside, but I have lots of molecules outside.
Oh, they're all
So my pressure outside is greater than the pressure inside, and it collapses the container. Okay? So that's an example of Boyle's law. Now we can put all those together. We've got our ideal gas law. Okay? All right, so every Friday, pretty much every Friday, we'll have a demo. Some will be loud and I will jump, like you have just seen. Others will be more visual, just kind of getting an idea for what's